You know that feeling, right? You're shopping online, your cart is absolutely perfect, you hit checkout, and poof, it's empty. Or maybe you get locked out of your bank account after just one wrong password. We've all been there, and it's so frustrating. But what if I told you that preventing these glitches isn't some kind of magic? It's actually a science. All right, so let's get into it. Building software that doesn't break is a real engineering discipline. So today, we're going to open up the Software Quality Engineers Toolkit and see how they make it all work. We'll start with the hidden logic inside software, then we'll check out 3 key tools they use to test its different states, its input boundaries, and the actual journey you take as a user. So what exactly are we talking about here? Software quality engineering isn't just about waiting for bugs to pop up and then squashing them like a game of whack-a-mole. Nope. It's a proactive discipline. It's a whole system for building reliability into the software from the very beginning, making quality something that's intentional, not just a happy accident. Okay, let's pull out our first tool. It's all about testing states and transitions. The best way to think about this is that software, kind of like a person or even a traffic light, has different states, or you could say moods. It's not always the same. And this tool helps engineers map out every single one of them. Now, the fancy technical term for this is a finite state machine. I know that might sound a little intimidating, but the concept is actually really simple. It just means a system has a limited or finite number of conditions it can be in. And here's the key thing. The exact same action, like clicking a button, can do completely different things depending on the system's current mood. And that action that moves it from one state to another, that's what we call a transition. So how do engineers actually use this idea? Well, they follow a really methodical 4-step process. First, they identify every single possible stable state the software can be in. Then, for each of those states, they figure out all the possible actions or events that could happen. Third, they map this whole thing out, usually in a chart or a diagram. And finally, they go through and test every single combination to make sure the result is exactly what they expect. To make this feel less abstract, let's bring it right down to earth with the simplest example you can possibly think of, a regular old light switch. It's actually a perfect, real-world finite state machine that you probably use every day. Think about it, right? A light switch has exactly 2 stable states, on and off. There's only one action, or transition, and that's flipping the switch. If you perform that action when the state is on, the new state becomes off. If you do it from the off state, the new state is on. It's simple, it's predictable, and it's a perfectly mapped system. Okay, now let's apply that same logic to something a bit more complex, like logging into your online banking. This table might look complicated, but it's just a map of every possible step, just like with the light switch. An engineer can use this to trace a path. For instance, to confirm that 3 wrong password attempts in a row correctly lead to state S7, account blocked. By mapping it out this way, they test every scenario and make sure you don't get locked out when you shouldn't. It's all about making the system predictable. All right, on to our second tool, and this one tackles a huge problem. I mean, imagine you're testing a field that accepts a number, say from 1 to 1,000. You can't possibly test every single number in between, right? That would be impossible. So how do you test effectively when you're facing what seems like infinite possibilities? Well, the solution is a really clever technique called domain analysis testing. The idea is to work smarter, not harder. The goal is to use the minimum number of inputs you possibly can to prove that the system handles the right data correctly and, just as importantly, rejects any data that's invalid or out of range. So how do they test so smartly? Well, they use this kind of 1-2 punch. First, they group similar inputs together into what they call classes. But here's the real secret weapon. They focus their testing on the boundaries. See, experience shows that bugs absolutely love to hide at the edges of an accepted range. So for a field that takes numbers from 1 to 1,000, they won't test 500. They'll test 0, 1, 1,000, and 1,001. The value's right on and just outside the boundary. Why? Because that's where the code is making a critical decision, and a tiny logic error there is all it takes for the whole thing to break. Now for our third and final tool. So far, we've looked at the system's internal states and how it handles data. This tool flips that perspective completely. It's all about testing the software from the outside in, by literally putting yourself in the customer's shoes and testing their complete journey. This approach is called use case testing, and really, it's kind of like writing a short story from the user's perspective. You figure out their goal, and then you map out how they'll use the software to achieve it. The beauty of this is that it tests the entire journey from the very beginning to the very end, making sure all the separate pieces of the system work together to create a smooth, single experience. So, let's build a quick use case. The goal is simple, and it's stated right here. A bank customer wants to use an ATM to withdraw some money from their account. That's it. That's our story. That's the user's journey. And this right here maps out that entire story, step by step. An engineer will follow this exact path. See, they're not just checking if the withdraw button works on its own. They're making sure the entire sequence, from inserting your card all the way to getting your receipt, is one seamless flow. It's about testing the experience, not just the features, to make sure it all comes together perfectly for you, the user. So there you have it. We've just looked at 3 really powerful tools from the Software Quality Engineer's Toolkit. Each one gives them a totally different lens to view and test a piece of software, making sure it's robust and reliable from every possible angle. So let's just pull it all together one last time. State transition testing maps the internal logic, all those hidden moods of the software. Domain analysis gives us a smart, efficient way to test data inputs by focusing right on those tricky boundaries. And use case testing makes sure the entire user story, that complete customer journey, is seamless from beginning to end. And that really brings us to the most important takeaway from all of this. That seamless app on your phone, that website that just works every time, that's not an accident. It didn't happen by chance. It is the direct result of deliberate, structured, and strategic engineering using tools just like the ones we've talked about today. So, I'll just leave you with this final thought. The next time you effortlessly buy something online or you log into your bank without a single hitch, take a second. Will you think about the hidden maps, the boundary tests, and the user stories, all the careful engineering that made that perfect experience possible?